This is problem 14 from section 3-5. So to begin a problem, it's often a good idea to take the diagram and fill in the givens on the diagram. So you can start by YD is congruent to ZD, so YD is congruent to DZ. So you can mark them with a hash mark, just to say they're equal. And then the second given, BD is equal to CD, so BD is equal to CD. So you can mark them with two hash marks. And finally, E is the midpoint of YZ, so E is the midpoint of YZ. So because the midpoint splits a segment in half, two equal halves, you can infer that these three are equal.
Now, we're going to start on some of the more proofs. You've got, for number 5, we can draw the line segment ED right here, because 2 points connected form a line segment right here. Now, we can prove that line ED is congruent to itself because of the reflexive property. Like this.
Using these three sides as congruent, we can tell that triangle YDE is congruent to ZDE because of SSS, side, 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 side 1, side 2, and side 3. And we can also prove that BDY, the angle, is congruent to CDZ because vertical angles are congruent. And now on these bow tie triangles, triangle BDY and CDZ, we have a side, an angle, and a side. So they are congruent by SAS, these two. And now that we know that, we know that this angle is congruent to this angle because of CPCTC, or corresponding parts of congruent triangles are congruent. And this angle right here, BYD, is congruent to this angle right here, CZD. And if we add two congruent segments, they make up a congruent angle. If we add two congruent angles, they add up one big angle using the addition property. And so now we can prove that angle BYZ is congruent to CYZ.